Hey, welcome back. In this video, we're going to discuss one of the most exciting features of C++, classes. We'll discuss the differences between classes and structs and how that difference involves access levels. Let's get started. Classes are user-defined data types. They contain their own variables, also known as members or member variables, as well as their own functions, also called methods or member functions. A new class is declared with the class keyword. So you declare a new class like this. You use the class keyword followed by the name of the class and a class body with a semicolon at the end. You can create a new variable of this type just like you would any other variable. Notice that this is similar to declaring a new struct type and creating a variable of that type. So what's the difference between a class and a struct? The difference is in the access levels. You see, the body of a class is private by default. That means its member variables and functions are inaccessible outside the class, whereas a struct has a public body by default, so its member variables and functions are accessible from outside the class. So what exactly does that mean? Well, we have experience working with the rectangle struct, and because this is a struct, its body is public by default, meaning its variables are public and we can access them from outside the struct. So let's say we create a rectangle in our code in the main function. If we attempt to access its member variable y and set it equal to a value, we can do that because it's public. Now, on the other hand, let's say we have a class, and that class has a member variable. By default, the body of a class is private, which means that this float variable is private. So if we create an instance of this class and then attempt to access this private variable directly and change it, we'd get an error because this float variable is inaccessible. It's private. So why would we make things private? Well, making the inner workings of a class private hides the details of that class and its implementation from the user, thus protecting the user from potentially messing things up. Say we have a class called car, and the car has the ability to brake. Now, as users of a car, all we need to be able to do to make that car slow down is press the brake pedal. We don't change the amount of brake fluid or the speed of the car ourselves. That's handled by the brake system. All we need to do is brake. This also helps with maintainability of classes. Let's say we improve the car class by introducing an ABS system that makes braking a lot more efficient and easier to use. As users of the class, we don't need to know about the inner workings of the brake. We still just press the brake pedal. If it were our responsibility to change all the variables required to brake, then that means every time the brake system changes, the user would have to learn those changes, and this introduces more possibilities for error. In your programs, if the data in your classes are private and hidden from other classes, this results in something called loose coupling, which means your classes are mostly independent. When the state of a class, or the current values of its variables, is hidden from the outside of the class, we call this encapsulation, and it's considered good programming practice when working with classes. Now, a class can have multiple sections, each with their own access levels, and we achieve this by the use of access modifiers. Notice the public and the private keywords here. You place the public keyword, followed by a single colon, to create a public section. All members and methods in that section are considered public, and you use the private keyword with a single colon to create a private section. So here we have a brake function, which is public, and three variables related to braking, which are private. So say we create an instance of this car class. If we attempt to access the private variables and change them directly, we'd get an error. But instead, if we call the public function, which takes care of the manipulation of those variables itself, then we eliminate the risk of braking incorrectly and messing up the calculations for these variables. The brake function here provides us with a public interface for the user of the class. The internal details can be left under the hood. So the challenge for you is to create a class. I want you to create the character class. Declare this class just above the main function. And all you're going to do in this class is create a public section and a private section, using the public and private keywords followed by colons. Pause the video and create this class. Okay, so here's our program, and just above the main function, we're going to create our class. So we use the class keyword followed by the name of our new class. Next, we need the class body, and at the end of a class body, we add a semicolon. So we want a public section, so I'm going to use the public keyword followed by a colon, and next we want a private section, so I'm going to use private followed by a colon. So now we have a public section and a private section in our new character class. Great job. That's enough for this video. In the next video, we'll work on adding some members and some methods to our character class so it'll be a little bit more useful to us. So in summary, we learned about classes and how we can create new classes and give them access levels, which designate their members and methods to be either public or private. This allows us to create encapsulation for our classes, which simply means that certain details of the class are hidden from outside of it, preventing the user of that class from potentially making errors and improving the maintainability of that class in case we wish to make changes and improvements for the future. We'll see you in the next video where we start to add more things to our character class. See you soon.